Hello, this is our first video for a circuit in series. You have 3 resistors, and they can be light bulbs or any other kind of resistors. The point is they are loads. They use electric potential energy and turn it into something else, whatever it might be. The point of this exercise is to figure out voltage and current in every single one of those resistors, and again there are 3. That 2 ohm, 4 ohm, and 6 ohm, as you can see them marked and drawn, which I already did, so you can pause this and draw it yourself and make sure that you mark all of them and also mark the plus and minus on the battery. And remember conventional current, which you have to show, because remember it shows direction of conventional current. Conventional current is the direction of the motion of positive charges through the circuit. That is because people started talking about electric current before they figured out what electron was. So that would be my direction of conventional current. It doesn't change. Its direction doesn't split anywhere. It's just one consistent flow. And this should remind you the rule about the current in a series circuit, and that is one consistent current through all resistors. In other words, current is equal in every single resistor in a series circuit. So then let's do the first step. In order to figure out everything, we need to figure out the equivalent resistance. And in our case, resistance equivalent is just the addition of R1 plus R2 plus R3. So our equivalent resistance for this particular case is 2 plus 4 plus 6, which is 12 ohms. Now, we know that the current is the same, and it's found as the total current, just using Ohm's law. Total, and in this case it's the voltage of the battery, total voltage over equivalent resistance. Total voltage, as you can see, is 72, and then you do resistance divided by 12. So 72 divided by 12, that would be 6. So our I total, I'm going to say I total is 6 amps, meaning I in 2 is 6 amps, I in 4 is 6 amps, and I in 6 equals 6 amps. They all have the same current. Well, then voltage in 2 is going to be 2 times 6, resistance times current, and it will be 12 volts. Voltage in 4 will be 4 times 6, 24 volts. And finally, voltage in 6 is going to be 6 times 6, which is 36 volts. Now remember, voltages add in a series circuit. So theoretically, if all our resistances are as shown, and therefore nothing else is using electric potential energy, like you remember in your lab you saw that wires actually do use a little bit of potential energy, and therefore we have a little bit of a drop of voltage. But we're pretending that our wires are ideal, have no resistance whatsoever. So if that is the case, then I should see the 12 plus 24 plus 36, that's 36 twice, that's 72 volts. Boom. So that's how you can check. 72 volts is the total voltage between the 12 and the 24 and the 36 for each individual. So if I were to mark it here, I would get 12 volts, 24 volts, and finally 36 volts over here. So this is how you find current and voltage across every single resistance in a series resistor when you are given the battery and all the resistances. So now after this, I would like for you to go to example 2, which is very similar. It's just it's 6, 2, and 8 as far as ohm, as far as resistance goes, and then your voltage of the battery is a little bit different. It's 48 volts, but you should be able to do it. So good luck.